All right, Algebra 1. Notes. Okay, so Algebra 1, we're going to be doing 9.4, solving quadratic equations, which we've been doing, but now we're going to do it by completing the square. It's kind of weird sounding thing. Completing the square. Make sure you put your name on your notes, date, period. Okay, so what is this all about? So what is completing squares? So completing the square which we will use for a couple different things on this assignment. One of them is solving quadratic equations. Completing squares where you take a quadratic polynomial, x squared plus bx, and you add some constant c. You add some number. Okay, so c, a constant, is just a number, it has no x's in it. You want to do it just right so that what you get, x squared plus bx plus c, that's what we're going to add something new here. We're going to add something new there, some c value, so that this is a perfect square. Okay, now what's a perfect square? Perfect square is where you have x plus or minus some number squared. You could write it like that. Okay? I'll write the steps down simply and then we'll see it worked out. You want to take half of b, okay? And b is the number in front of the x term, just the x to the first power, okay? So that's first step, half of b. Step 2, you're going to square that half of b, okay? Step 3 is you're going to add it to both sides of the equation, if you have an equation, okay? So let's, we're going to do several examples so you kind of see it in use, okay? So example 1, the directions are going to be complete the square for each expression. Then factor the trinomial. Okay? Our first problem is going to be x squared plus 6x. Now, this is not an equation, okay? So it don't have an equal sign, so you can't solve it. You can only solve equations that have equal signs and two sides. But we're going to just manipulate it. We're going to change the way it looks, which is kind of just a stepping stone to doing something a little more complicated. So what we're going to do is we're going to add something here. Okay, we're going to add some new number here, just the right number, so that we can write it eventually like this, so we can factor it into something really pretty, perfect square. It's always the middle term divided by 2 squared. Those parentheses matter because that means you do the division first and then you do the exponents. Otherwise, exponents usually come first. Okay, so that's going to be x squared plus 6x plus 6 divided by 2 is 3, squared is 9. So we've added a 9. That wasn't there before. And after we do that, we should be able to factor this. Two binomials, you need an x and an x, right? These two things make that. And how do you get a 9 by multiplying two things? 3 and 3. Positive has to add up to positive 6. So you guys should be getting the hang of factoring from previous lessons. And we could just write it like this, x plus 3 squared, because it's the same exact thing times itself. So that's what we're trying to do on these. Okay, let's do another one. Example B. We'll make this one a little messier. X squared minus 9x. So that's the problem. We want to add something new here. I like to just draw an empty box. Now, whatever this is, it's half of the middle term, including any sign in front of it. Last time it was positive, so just don't write the positive. But this is minus 9, so that's a negative 9 divided by 2 squared. Okay? So we're going to get x squared minus 9x plus, now negative, you can square the top and square the bottom. Rules of exponents. Square the top, square the bottom of a fraction. The top, negative 9 times negative 9 is positive 81. Bottom, 2 squared, 2 times 2 is 4. Okay? Now we're going to try and factor it. So we know we're going to get two binomials, x and x, right? And then we got to find two numbers that multiply together to get 81 over 4, but add up to negative 9. Well, guess what? It's that number that was inside the parentheses. Minus 9 halves. Minus 9 halves, right? 9 halves times 9 halves is 81 over 4. If you make them both negative, they give you negative 9 wholes. So use this work to help you figure out what's going to go in here. This last time it wasn't as hard, but that's all it is that number we get when we factor it was that number in the parentheses before we squared it. And then we write it like this, squared. Okay? Now, why are we doing this? So like I said, that was just kind of a little warm up. We're going to use this. We got a little practice doing it, but we're going to use this now to solve by completing the square. Solve by completing the square. So solve means we weren't solving because those weren't equations. It means we're going to get an equation. So x squared minus 16x equals negative 15. Okay, this is an equation. It has an equal sign. Now we actually in previous problems we'd usually move this over here, but we want this here for now. Okay. If it's not here, if it's over here, we want to actually move it over to the other side. This one's ready to go. I'll show you one next that isn't. So that's actually good. Now we're going to rewrite this because we want to complete the square over here. So we want to add something new. Now that's okay as long as this is a rule for equations that we've been using for a long time. You can do whatever you want to one side of an equation as long as you do the same thing to the other side. So if we add something new here, we need to add it over here too. Now, the thing we want to add right here is half of b, the number in front of the x, negative 16 divided by 2, half of it squared. Okay? What is that going to be? Negative 8 squared is positive 64. So we just added a 64 right here, right? And we got to add a 64 to the other side. I'm just going to write 64 because that's what it is. I'm just showing my work here a little bit. But it's a 64. In fact, I'm going to rewrite this, x squared minus 16x plus 64. And then over here, I can go ahead and combine these. 64 minus 15, 15 at 49, right? 64 minus 15, 49. So we've completed the square. We're done completing the square. But now we can use this to help us solve it, okay? So we're going to factor this just like we did on the last problem, so we've got to factor this. Right-hand side, this 49 is just hanging out. Okay, pair of numbers that multiply get 64 and add together to get negative 16. By the way, hint, it's the thing that was inside the parentheses before you squared it, negative 8, minus 8, minus 8. That's what should happen. That's why we're picking this perfect number, is so that this does happen. If this doesn't happen, you pick the wrong number. We're forcing this to happen. Okay, and then we write it like that. So we completed the square, and now we've rewritten it as a perfect. This is called a perfect square. Something squared. That's a perfect square. Now we want to solve for x. Okay, this is finally where we're going to solve. Okay, so we completed the square, then we factored it, and now we're going to solve it. Now the way to solve it, you want to get x by itself. So you want to undo the things that are outside of it, starting from the outside, working to the inside, reverse order of operations. To get rid of a squared, you got to take the square root. Whatever you do to one side, you got to do the other side. But there's this extra rule that when you take the square root of both sides, you got to do plus or minus. Because there's two different ways you could get 49 by squaring something. It could be 7 times 7, or it can be negative 7 times negative 7. On the left, we just have x minus 8. The square root and the square root cancel each other out. Over here, we have plus or minus 7. Usually you get two answers for parabolas. These are like x-intercepts of parabola. Then we're going to, from here, we're going to write two equations. We have x minus 8 equals positive 7 and x minus 8 equals negative 7. This represents two different possibilities. So we can split them up and then finish solving. X equals 15. X equals positive 1. Those are your answers. Okay, so that's how we solve by completing the square. Let's do another one like that. Okay, we'll call that A. We'll call this one B. This one's going to have an extra challenge, couple extra challenges to it. Okay, now here's the deal, and we haven't talked about this yet, but to complete the square, you really want a 1 in front of, you want a 1 in front of the x squared. If you don't have a 1, you're probably not going to be able to complete the square. So in this case here, we want this to be a 1. Okay? Now with an equation, we could divide both sides by 2. I'll show you another possibility maybe after this one. Divide both sides by 2. Whatever you do one side, you go to the other. Division, multiplication, you get distribute to each term. So 2x squared divided by 2 is x squared, plus 20x divided by 2 is 10x. Minus 8 divided by 2 is minus 4. 0 divided by 2 is 0. So we want this to have a 1 in front, which we usually don't write. But we want it to have a 1 in front. Now, this 4 right here, this minus 4, it's just hanging out. It is probably not the perfect number we want. So what we usually do is we move it to the other side. Any number, any c value that's already there, let's get rid of it. Let's move to the other side. So that we can rewrite this as x squared plus 10x plus box equals 4 plus box. Okay. The minus 4 is not what we need to complete the square. So we move it over to the other side, get it out of the way. Now we're going to put the perfect thing here, which is always half of the b term in front of x squared. 10 divided by 2 is 5 squared is 25. We just added 25 to both sides. If you do it to one side, you got to do it to the other. Now over here, I'm going to go ahead and combine these together. It's 29. Okay, this is where the completing the square is happening. All the extra stuff ends up over here. We'll deal with it later. We want to factor this, right? X and x. What two numbers multiply together get positive 25, add together get positive 10. Hint, it's the number that was inside these parentheses. 10 divided by 2 is 5, positive 5 plus 5 plus 5. And then we can rewrite it as squared. Okay, so we completed the square, right? We factored it. And now we're going to solve. Now the way to get rid of this squared is to take the square root of both sides. You can only do that if you have one thing squared. That's why we couldn't do that. We can't do that at the beginning. Be like, oh, I'm going to get rid of this squared. I'm going to take square root of both sides. Yeah, but you can't just do it for one term when there's a bunch of terms. You got to do it to the whole side. And doing it to the whole side up here wouldn't make sense either. It wouldn't help you. Plus or minus. Don't forget the plus minus. So we have x plus 5 equals plus or minus. Now the square root of 29 is not nice. And we have learned how to simplify radicals recently, and there's nothing you can even take out of it. So we get two possible answers. X plus 5 equals positive square root of 29, and x plus 5 equals negative square root of 29. And we're going to subtract 5 and subtract 5. Now, I can't combine these together. So I'm going to put the negative 5 first and then plus square root of 29. They're being added together. You could do square root of 29 first. And over here, I'm going to subtract 5 from both sides. So I'm going to get x equals negative 5 minus the square root of 29. Those are your two answers. Now, you might be asked to write your answers as a decimal. So if they do that, you just got to get a calculator and know how to type it in. And it might say, they might want a decimal to the nearest hundredth. Okay, nearest means we're going to round it. Okay, hundredth is the second decimal place after the decimal point. Okay, so the way we type this in is we do negative 5 plus second. There's the square root button. You don't want this one. You want this one. Square root 29, close parentheses, equals. This one's going to be, and so we're rounding it, so it's an approximation. So a lot of times we use these equal signs. It's like about 0.39. So rounding, this is tenths, hundredths. That's the last number we want in our answer. But when we round, you got to look at the next number. If it's 5 or more, you round up to 9. If it's less than 5, you round down to 8. So that's that one. And then we do negative 5 minus the square root of 29. And we get negative 10.39 for that one. Negative 10.38 rounded up to a 9 because there's a 5 there. So that's how you deal with the decimal on your calculator. Okay. Now, I guess I could show that problem one more way because it's kind of up to you, but this might make more sense on another one. So let me just show you real quick. One more way, just the beginning of it. So if we had that, the big issue is this 2 in the front. And we did it one way before. Now what we could do is we could actually move this 8 over here right away. We waited. Okay, and then we could factor the 2 out of just these. And then you're going to put your extra box inside here. And then that means you would add a box over here. But really, the box you're adding to the left side is getting multiplied times 2. So this box needs a 2 times in front of it also. I'm going to show you. This will give us the same answer. It kind of depends on which way you want to do it. This method is better for the next problem. One of the next problems I'm going to show you. Now, this number right here is the middle term, 10 divided by 2 squared, which is 5 squared is 25. And that's the same number we got last time. We got 25, right? And so we get x squared plus 10x plus 25 equals, that's going to be 58. Now we could factor this, x plus 5, x plus 5. We could write it like this, x plus 5 squared. Now you don't want to do the square root first here because you want to get rid of, you want to work from the outside in. So you want to divide both sides by 2. So this one would probably have been easier to just do it the way I showed you before. But eventually, we're back down to where we were last time, right? So the rest of it's the same. Anyways, I don't know. I just thought I'd show you that alternative approach to the last problem of dealing with the number in front that wasn't a 1. Now, I might kind of take that approach on another one. So here's another example. Example 3. This one we're going to find the minimum value of y equals x squared plus 4x minus 1. Now I'm going to do another problem over here, so see if you could save some room. So example 4 is going to be here. That'll be our last example. Okay, so example 3, find the minimum value. Now we've done this before. Minimum value, parabola. Parabolas either open up, and the min is down here at the bottom at the vertex, or they open down, and you get a max value. So it's a min or a max. If they say min, then I'm assuming it is going to open up. And we can tell right now if it opens up or down by the a value in front. If the a value is positive, it opens up. But we got some work to do. We want to put this, we want this in vertex form. Okay, now vertex form, this is going to use what I taught you today, is y equals ax minus h squared plus k. And the vertex is at hk. And the vertex has the maximum value in it. So we're going to use complete and square to make it look like this first. So, okay, here's the deal. This is where we're going to complete the square. We want to move this to the other side. Before there was nothing over there. There's a y now, so it's going to be y plus 1. We're going to add something new to both sides to complete the square. So I'm going to write it as a little box equals, or plus box equals x squared plus 4x plus box. Okay, this is where we're completing square, but what do we do one side? We got to do the other side. And the extra number that's there, we just want to move it, get out of the way. This number is going to be the b value divided by 2 squared. So that's going to be 4 divided by 2 is 2, squared is 4. We're adding 4 to both sides. We just added 4 to both sides. Okay? Let's factor this now. Left-hand side is just hanging out. It's going to be x plus 2, x plus 2. And then we're going to write it as y plus 5 equals x plus 2 squared. Now we're almost to vertex form. Look, there's that part. The a value must be 1. We got to move this k value back to the other side. We got to subtract 5 from both sides. So our final vertex form is y equals x plus 2 squared minus 5. That's our vertex form. I'm going to use that. We're going to say, okay, this is the a value. The h value is negative 2. It's the opposite of what you see there because it comes from x minus h. So you have to think, well, what would I plug in h to get plus 2 here? Well, since it's minus, you'd have to put another negative 2 there for it to come out as plus 2. The k value is just exactly what you see. K equals negative 5. Okay? So from that, the vertex is h comma k. And for us, that equals negative 2, negative 5. Now, since a equals 1, which is positive, the graph opens up. So since a is positive, the graph opens up. And the vertex is a minimum, lowest value on the graph. Okay? And the min value is the y value. Min value is negative 5. Okay, so the min value is the y value of the vertex. right here. Okay. So that's how we do it. We're going to do one more example. This time it's going to say find the maximum of y equals negative x squared plus 2x plus 7. Okay. Now, we don't want, well, one, we know this graph is going to open down, right? So that it makes sense that they're asking for a maximum because the graph is definitely going to open down and give you a max because the a value is -1. Okay. But for completing square, we don't want anything in front of the x squared other than +1. So we got to deal with that negative. Now, one way you could do it is you could divide both sides by -1, everything, including the y, and that would work. But it would be a little further from vertex form. You would have to do a couple extra steps later. It's up to you if you think it's worth it or not. But I'm going to subtract 7 from both sides. Okay. And to take care of this, I'm going to do what I showed you up here. I said you could factor it out. So I'm going to factor -1 out of the x squared and the 2x, so you get -2x. Okay. Now we're going to add something to both sides. We've got to complete this square. And that extra thing needs to go inside these parentheses. This is where the completing the square is happening. Okay. Now here's the deal. We added a new box here, so we're like, we got to add one over here. But really, this one's going to get multiplied by -1, so this one needs to get multiplied by -1. You got to balance it out. Here, this is going to be half the middle term divided by 2 squared. So it's going to be -2 over 2 is -1 squared. It's +1. So we added a +1 there. So now we have y -7 minus 1 is -8. We're going to factor this. -1 minus 1. Remember, two numbers that multiply together you get +1, but add together you get -2. But by the way, it is the way we got this one was by taking the middle term and dividing by 2. That value is what ends up down here. So there's a negative, so it's -1. Factor it. Right squared. Now we want to get we're going for vertex form. So this -8, we want to move back over to the other side. Okay, so this is your a value. Your h value is +1. Your k value is +8. So you remember your h is always opposite of what's there. So your vertex is at 1, 8. And since a equals -1 is negative, the graph opens down and you get a max at the top, at the vertex. So the max value is the y value of the vertex, 8. Okay, so for classwork, we're going to do monitoring progress. Monitoring progress. We're going to do page 506, problems 1 through 9 all. And so try it out yourself. This is kind of a complicated process. You practice it, you should start to get the hang of it. There are little videos on monitoring progress that'll show you how to do the problems. If you're like, man, I don't know if I'm doing this right, or I don't know how to do this, press the little play button on the Student Dynamic ebook for each of them, and it'll show you how to do it. Until you feel like you know how to do it, then try it yourself. before you go to your assignment, before you do the quiz. All right.